The Realistic Retarder Model, added in ASAP 2008, is a complement to the Realistic Polarizer Model. It's a uniaxial crystal thin layer model. It's denoted by the command RRM to create it. It's applied to an interface using the interface polarization command. In this case, it's a retarder type. What we're looking at is a pair of crossed realistic polarizers with a realistic retarder between them. The realistic retarder is a fairly thick retarder. We send in an input cone of light, which is very broad, about at 88 or 89 degrees, and take a look at what is transmitted. So we will use this as a ratio to the output polarization to show the performance as a throughput. And that ratio is shown in this diagram. We see a Maltese cross, as we do with cross polarizers in general, but because of the multiple waves of retardants, we see multiple nulls along the diagonals with bright areas between them. This is a hallmark of polarization interference of a thick retarder enclosed between two crossed polarizers. Another model we'd like to look at is a retarder with retarding compensators, and that retarding compensator stack is used to make the off-state performance of a liquid crystal cell, for example, as low as possible. So this is the transmittance as a function of direction for a simulated liquid crystal cell. It is dark in the middle because it is an off state. We want to have the transmission as low as possible. So in the center, its performance is very good. Along the diagonals, its performance is very good. But along the x-axis direction, there are a couple of bright spots near the edges of the visual field. And a good compensator design seeks to minimize that, and in fact can reduce it by orders of magnitude. In summary, the Realistic Retarder Model, added in ASAP 2008, is a sophisticated, broadly capable model, which complements the other devices.